Welcome back to part two of this presentation. AI, from what's that to that. A crash course in artificial intelligence and machine learning for the blissfully unaware. Let me again welcome you back to part two, AI enthusiast. I hope you've all recovered from the mind-bending journey through part one of our AI adventure. You know, the one where we time traveled through AI history, unraveled the mysteries of machine learning, and contemplated whether the robots will one day rule us all. Just kidding. Or am I? Now buckle up because we're about to dive headfirst into part two. The Intelligent Agents Spectacular is like part one, but with more personality, literally. Let's peek at today's lineup of brain-tickling topics. First up, we'll introduce you to intelligent agents. Think of them as the overachieving cousins of the AI family. They're not just smart, they're proactive. Next, we'll explore agent architectures. It's like HGTV for AI. We'll see how these digital divas are structured to strut their stuff. Then we'll eavesdrop on agent communication and coordination. It's basically a lesson in how to get AI to play nice in the sandbox altogether. Moving on to learning in multi-agent systems. Imagine a classroom full of AIs, each trying to outsmart the other. Sounds like fun, right? We'll then jump into agent-based modeling and simulation. It's like The Sims, but for solving real-world problems instead of creating drama in virtual neighborhoods. After that, we'll chat about mobile and ubiquitous agents. They're the AI equivalent of that friend who's always everywhere in a good way. And for our grand finale, we'll gaze into our crystal ball at the future directions and challenges in intelligent agent systems. Spoiler alert, flying cars may or may not be involved. This whirlwind tour of intelligent agents will leave you with a brain full of AI goodness, perfectly complementing the feast of knowledge from part one. So, are you ready to meet the smartest non-humans you'll ever encounter? Let's dive in and see what makes these intelligent agents tick, or should I say, compute. Ladies and gentlemen, put your hands together for the stars of our show, intelligent agents. These autonomous software superstars are the AI world's answer to Swiss Army knives. They perceive, they think, they act, and they might just be smarter than your average toaster. Let's peek behind the curtain and see what makes these digital divas tick. Definition and concept. Imagine if your smartphone grew legs and started doing your chores. That's kind of what an intelligent agent is like. They are the multitasking marvels of the AI world, equipped with sensors to take in the world and effectors to shake things up. They're like little tiny AI organisms trying to survive and thrive in the wild, wild world of data. Key characteristics. These agents aren't just smart, they're the whole package. Autonomy. They're the teenagers of AI, independent and don't need you hovering over them. Reactivity. Quicker than a car on a hot tin roof. They respond to changes faster than you can say artificial intelligence. Proactiveness. They don't wait for opportunity to knock. They build the door and install a doorbell. Social ability. They're the life of the party, chatting up other agents and humans alike. Types of intelligent agents. We've got a buffet of agents, each with its own flavor. Simple reflex agents, the sprinters of the AI world. Fast, but not too deep. Model-based reflex agents, the Sherlock Holmes of agents, keeping track of clues. Goal-based agents, the chess players, always thinking 5 moves ahead. Utility-based agents, the economists, always weighing costs and benefits. Learning agents, the eternal students, getting smarter with every mistake. Architectures for intelligent agents. Let's peek under the hood and see how these brainiacs are wired. Reactive architectures. The act first, think later crowd. Great for doorbell. Not doorbell, sorry. Great for dodgeball is what I meant. Great for dodgeball, not so much for chess. Deliberative architectures. The overthinkers. They'll get it right. Eventually. Hybrid architectures. The best of both worlds, quick on their feet and smart to boot. BDI architecture. BDI. B stands for belief, D stands for desire, and I stands for intent or intention. BDI architecture is like giving an agent a tiny philosopher brain. They believe, they desire, they intend. Relation to AI and software development. These agents aren't just showing off. They're revolutionizing how we approach AI and software. They're naturals at modeling complex systems. It's like The Sims, but for serious stuff. They're flexible enough to star in their own action movies. They're modular, like Lego bricks of intelligence. Applications. From robots that might one day beat us at soccer, watch out, Macy, to software that manages your life better than you do. These agents are everywhere. And just when you thought it couldn't get any cooler, we've got multi-agent systems. Imagine a whole team of these digital dynamos working together. It's like the Avengers, but with more algorithms and less spandex. So buckle up, Buttercup. We're about to dive deep into the world of these AI superheroes. Who knows, by the end of this, you might just want an intelligent agent of your very own. Now let's get on a whirlwind tour of agent architectures. It's like extreme makeover AI edition, but instead of houses, we're remodeling digital brains. Reactive agents. Meet the Usain Bolts of the AI world. You know Usain Bolt, right? Usain Bolt is a world famous Jamaican sprinter who is widely considered to be the greatest sprinter of all time. He holds the world records for the 100-meter and 200-meter, I think, races, and has won 8 Olympic gold medals. Anyways, these speedsters react faster than a cat on a hot tin roof. I know I said that before. They're all about that stimulus response life. No time for deep thoughts here. Subsumption architecture. It's like a layer cake of behaviors, but instead of frosting, each layer can boss around the ones below. Thanks, Rooney Brooks, for this robotic hierarchy. There are pros and cons to this reactive agents category. The pros: fast as lightning, tough as nails, and scales like a lizard. Cons: not so great at long-term planning or learning new tricks. Next up is deliberative agents. These are the chess grandmasters of AI. They've got a whole world in their heads and they're not afraid to use it. Planning-based agents. Ever heard of STRIPS, STRIPS in all capital letters? No, not the casino kind of strips. It's a planner that turns the world from meh to yeah, one step at a time. Pros: great at solving complex puzzles and thinking ahead. Cons: slower than molasses in January and can get confused in chaotic situations. Hybrid architectures: why choose when you can have it all? These are the combo meals of the AI world. Fast food speed with gourmet planning. Layered architectures is like a 3-layer dip of AI goodness. Reactive salsa, deliberative guacamole, and interface cheese holding it all together. Turing machines and InterRAP. Now, InterRAP is actually an acronym. RRAP. R are in capital letters, A, and then P is in capital letters. These are fancy names for let's stack some AI and see what happens. Pros: versatile as a Swiss Army knife and adaptable as a chameleon. Cons: can be as complicated as rocket science, and sometimes the layers fight like cats and dogs. Lastly is we want to talk about BDI framework. BDI, again, B stands for belief, D stands for desires, and I stands for intentions. Imagine giving an AI a philosophy degree. That's BDI for you. It's all about beliefs, desires, and intentions, like a digital soap opera. Jack Intelligent Agents Framework, Java-based BDI on steroids with a rational database for a memory. JACK, J-A-C-K, this is not an acronym. I found that this is actually a brand name for the framework rather than an acronym. It's quite common in software development to choose names that are easy to remember and pronounce, even if they don't have a specific meaning related to the software's function. So this is one of those. Pros: mixed decisions like a rational human on a good day. Cons: can get stuck in existential crisis and doesn't always play well with others. In conclusion, these architectures are the secret sauce that makes AI agents tick. Whether you need the speed of a reactive agent, the brains of a deliberative one, the versatility of a hybrid, or the philosophical musings of a BDI agent, there's an architecture for every AI dream. So let's raise a glass to these architectural wonders. May they continue to evolve, innovate, and maybe one day build us that robot butler we've all been waiting for. Wouldn't that be nice? We are about to dive into the wild world of agent communication and coordination. It's like a high school dance, but instead of awkward teenagers, we've got suave AI agents busting moves on the dance floor of problem solving. That's quite an image there. Agent communication language, ACLs, not access control list, no. Here in this context is agent communication languages. Picture this: AI agents with their own secret language, complete with digital high fives and robot emojis. We've got two cool kids on the blog, FIPA-ACL and KQML, sorry. HIPAA-ACL stands for Foundation for Intelligent Physical Agents, ACL, which is Agent Communication Language, and KQML stands for Knowledge Query and Manipulation Language. They're like the Coke and Pepsi of agent chat apps. So FIPA-ACL, the new kit with the fancy IEEE badge. IEEE is, stands for IEEE stands for Institute of Electrical and Electronic Engineers. This is like a new kit with a fancy IEEE badge, speaking in performatives like a Shakespeare of the digital age. To inform or to request, that is the question. It actually provides a structured way for intelligent agents to exchange messages and information, enabling them to cooperate and coordinate their activities in multi-agent systems. What about KQML, Knowledge Query and Manipulation Language? This is the OG of agent chit-chat. Again, OG stands for original gangster. The original gangster of agent chit-chat, all about the knowledge-sharing life. It's like the wise old guru of the mountain, but for AI. Coordination mechanisms. Now let's talk about how these agents work together without stepping on each other's digital toes. Blackboard systems. Imagine a giant cosmic whiteboard where agents scribble their thoughts. It's like a brainstorming session, but way cooler with less coffee stains. Tuple spaces. Think of it as a game of digital hot potato, but with data instead of spuds. Agents toss around these tuples like they're playing the world's nerdiest game of catch. Market-based approaches is like Wall Street, but for robots. Agents wheeling and dealing, buying and selling tasks like they're trading stocks. Buy low, compute high, as they say. Negotiation protocols. This is where things get diplomatic. It's like the United Nations, but for AI. Contract net protocol. Picture a talent show where the manager is shouting, "Show me what you got," and all the contract agents are doing their best robot dance to win the gig. Auction-based protocols. It's eBay for all. Do I hear 50 computations? 100 computations. Sold to the shiny robot in the corner. Augmentation-based negotiation. Imagine a debate club for AI, where instead of shouting, they exchange logical arguments. It's like a rap battle, but with more algorithms and less beatboxing. Semantic interoperability. This is the universal translator of the AI world. It's ensuring our digital pals don't end up in a lost in translation comedy. Ontologies. It's like giving all the agents the same dictionary, so when one says Apple, the others don't think it's talking about smartphones. Semantic web technologies. Turning the wild west of the web into a well-organized library where agents can find exactly what they need. It's like Google, but for AI eyeballs. Challenges. Because nothing's perfect, right? We've got ontology alignment, making sure everyone's on the same page. We've got context dependence, because sometimes cool means awesome and sometimes it means chilly. And we got scalability, trying to keep the party going when more and more agents show up. So there you have it, the grand ballroom of agent communication and coordination, where AI entities dance the night away, solving problems and making digital magic happen. It's a brave new world, and these agents are ready to paint it in algorithms and awesome. Now, grab your virtual pencils and put on your thinking caps, because we're diving into the wacky world of learning in multi-agent systems, MAS in short. It's like a high-tech kindergarten where AI agents are the students and the world is their playground. Importance of learning in MAS, in multi-agent systems. Picture this. Our AI agents are like sponges, soaking up knowledge faster than a cat video goes viral. They're adaptability ninjas, changing their game plan quicker than a chameleon on a disco floor. They're coordination maestros, singing up like the world's geekiest flash mob. They're performance enhancers, getting better with age, like a fine digital wine. Types of learning in MAS. Our AI pupils have more learning styles than a hipster cafe has coffee options. individual versus collective learning, solo study sessions, or the ultimate group project. Supervised learning, like having a helicopter parent but for data. Unsupervised learning, throwing agents into the data pool and yelling, swim. Reinforcement learning, giving agents gold stars or timeouts for their actions. Transfer learning, using math skills to ace a physics test. Meta learning, learning how to learn. It's so meta, even for this acronym. Game theoretic perspective. It's game night in the AI world. Nash equilibrium, where everyone's a winner or at least not a loser. Evolutionary game theory, survival of the fittest, but with algorithms. Cooperative versus competitive scenarios. Sometimes it's kumbaya, sometimes it's every agent for themselves. Challenges in multi-agent learning. Because life, even for AI, isn't all rainbows and unicorns. Exploration versus exploitation. To boldly go where no agent has gone before, or stick to the tried and true. Non-stationarity. The only constant is change. And boy, does that make things tricky. Credit assignment problem. Who gets the gold star when everyone's working together? Scalability and sample efficiency. Making sure our AI classroom doesn't turn into chaos as it grows. Partial observability, when agents have to make decisions with blindfolds on. Heterogeneity, imagine a classroom where some kids speak Klingon, others do interpretive dance, and a few communicate via interpretive dance. Emerging research directions. The cutting edge is so sharp you could slice a digital pizza with it. Multi-agent deep reinforcement learning, teaching old dogs new tricks and new dogs even newer tricks. Federated learning, sharing is caring, but privacy is privacying? Don't know. Explainable AI, because sometimes even AI needs to show its work. So our AI agents are out there learning, growing, and occasionally stubbing their digital toes. They're turning the world into one giant, crazy smart classroom. Who knows, maybe one day they'll be smart enough to do our homework for us. Just kidding, kids. Stay in school. Let's go on another wild ride through the wonderland of agent-based modeling, ABM in short. It's like SimCity, but for nerds with PhDs. Principles of agent-based modeling. Imagine you are the puppet master of a digital universe where each little agent dances to your tune. Bottom-up approach. It's like making a gourmet meal by starting with individual ingredients. Suddenly, you've got a 5-star dish, and you're not quite sure how it happened. Emergent behavior. Picture a flash mob, but instead of dancers, it's data points. 1 minute they're minding their own business, the next they're doing the Macarena. Oh, you know what Macarena is? The Macarena is a Spanish dance song by Luis Dario that became a global sensation in the mid-1990s, I believe. You may not be old enough to remember that. It's famous for its catchy tune and simple dance moves that anyone can do, or at least attempt. Anyways, next item is heterogeneity. It's a digital potluck where every agent brings a different dish. Some bring pineapple pizza, others bring quantum physics. It's wild. Spatial aspects, like a game of musical chairs, but the music never stops, and the chairs are multidimensional. Simulation platforms. We've got more platforms than a shoe store. Net Logo, the Lego of ABM. Build your own model, brick it, rebuild it, no glue required. Meson, for when you want your simulation to run faster than a caffeinated cheetah. Riposte, the Swiss Army knife of ABM. It slices, it dices, it simulates complex adaptive systems. AnyLogic, the James Bond of simulation platforms. Smooth, sophisticated, and licensed to model. Applications of agent-based simulation. ABM is the cool kid at the interdisciplinary party. Social sciences, modeling how gossip spreads faster than a viral cat video. Ecology, simulating nature's drama. Will the bunny escape the fox? Tune in next time. Economics, like fantasy football, but for stock markets. Urban planning, SimCity, but with more traffic jams and fewer alien invasions. Epidemiology, zombie apocalypse simulator, also works for regular diseases. Challenges in large-scale simulations is not all fun and games. Well, it is, but with some hurdles. Computational scalability, when your simulation needs more computing power than NASA. Model validation, convincing skeptics that your digital world isn't just a fancy screensaver. Data requirements, hunting for data like it's the last roll of toilet paper in a pandemic. Interpretation of results, when your simulation predicts the rise of sentient toasters and you're not sure if it's a bug or a feature. All right, future directions. Hold on to your hats. As I always say, integration with machine learning, teaching our digital minions to think for themselves. What could go wrong, right? Hybrid modeling is the modeling equivalent of a turducken. You know, turducken, turkey and duck and chicken, I believe. Delicious, complex, and slightly terrifying. Participatory ABM, where the stakeholders and the simulators hold hands and sing Kumbaya. Real-time ABM, for when you need your simulation to be as up-to-date as your Twitter feed. So that's about it for this slide, agent-based modeling, where we play God with digital ants and hope they don't form a rebellion. It's turning the whole world into a giant science experiment, one agent at a time. Who knows? Maybe one day we'll simulate our way to world peace, or at least figure out why the office printer always jams. Up next is another wild ride through the wonderland of mobile and ubiquitous agents, the James Bonds of the AI world. Mobile agent systems. Picture this, tiny digital ninjas packing their code suitcases and teleporting across networks faster than you can say Wi-Fi. These tech-savvy nomads are here to save the day, and maybe your bandwidth too. Agent migration is like playing the floor is lava, but with servers instead of furniture. Benefits. They're the superheroes of load balancing, network traffic reduction, and offline operations. No cape required. Challenges. Dealing with picky hosts, performance hiccups, and keeping our digital ninjas from going rogue. Platforms. Agglets. Java's gift to mobile agents. Jade, not the gemstone, but just as precious. And Voyager, boldly going where no agent has gone before. Context-aware agents. Imagine having a butler who not only knows how you like your tea, but also predicts when you'll want it. That's context-aware agents for you. Sensing and adapting. They're like that friend who always knows what you need before you do. Personalization, your very own digital Jeeves, anticipating your every whim. Ambient intelligence, turning your home into a smart paradise. It's like living in the Jetsons, minus the flying cars. For now. Internet of Things, IoT and agents. Welcome to the ultimate playground for our agent friends, a world where your toaster might be smarter than you. Edge computing, bringing AI to the edge. It's not a U2 album, but it's just as revolutionary. IoT device management, herding digital cats has never been so efficient. Data processing at the edge, because sometimes what happens at the edge stays at the edge. Coordination in IoT is like conducting an orchestra, but instead of violins, you have smart fridges and traffic lights. Security concerns. Even our digital superheroes need their kryptonite-proof suits. Sandboxing, keeping our agents in check. No building sandcastles allowed. Trust management, teaching our agents the stranger danger of the digital world. Code integrity, making sure our agents don't come back with digital tattoos that they'll regret. Privacy preservation, because what happens in Vegas should definitely stay in Vegas, especially if Vegas is your smart home. Future directions. Again, hold on to your hats. The future is so bright. Well, here it comes again. You'll need shades, which is true. It's going to be very bright. I know I've said that many times before. Can't think of anything better to say. Anyway, the future is bright. Blockchain for agent trust, making our agents more trustworthy than your average politician. AI enhanced security, teaching our agents to be their own bodyguards. Quantum safe cryptography, preparing for a future where Schrodinger's cat might actually encrypt your data. Schrodinger's cat, from the physics, quantum mechanics. Yes, quantum mechanics, Schrodinger's cat. Federated learning in IoT is like a study group for your smart devices, but way cooler. The bottom line here is mobile and ubiquitous agents are turning our world into a sci-fi utopia, one smart toaster at a time. Who knows? Maybe one day these digital nomads will solve climate change, or at least figure out why the Wi-Fi always drops when you're in the middle of a Netflix binge. All right, we are towards the end, and we are about to blast off into the future of intelligent agents, a world where your toaster might outsmart you, but at least it will make perfect toast. Integration of AI and agent technologies. Again, picture this. We're mashing up AI and agents like it's a DJ set at the nerdiest club in town. Deep learning plus agent architectures equals a match made in silicon heaven. Neurosymbolic AI is like giving our agents a PhD in philosophy and a black belt in pattern recognition. Reinforcement learning, teaching agents to adult better than most humans. Federated learning is like a secret book club for agents, but instead of novels, they're sharing knowledge. Ethical considerations, because we don't want our AI overlords to be jerks, right? Accountability, making sure our agents don't pull the dog ate my homework excuse. Alignment with human values, teaching robots the golden rule and hoping they don't take over the world. Fairness and bias mitigation, because even AI should learn that judging a book by its cover is so last century. Privacy preservation, keeping your data safer than your secret cookie stash. Scalability and real-world deployment. Time to take this show on the road. Large-scale multi-agent systems herding millions of digital cats. Efficient coordination like synchronized swimming, but with algorithms. Robustness and adaptability. Creating agents tougher than a Nokia 3310. Oh, you remember the Nokia 3310? I sort of remember. The Nokia 3310 is a GSM mobile phone that was first released by Nokia in September of 2000. It quickly became one of the most popular and beloved mobile phones of its time, achieving an almost mythical status in popular culture. That's Nokia 3310, in case you don't know what it is. Integration with existing infrastructure, making sure our fancy new agents play nice with the old school tech. Human-agent interaction, teaching our silicon friends some social skills. Collaborative and competitive scenarios, from teamwork to trash talk. Our agents do it all. Natural language interfaces, because talking to your computer shouldn't feel like you're in a bad sci-fi movie. Explainable AI. Why did you do that, Hal? Well, let me break it down for you, Dave. I cannot talk sexy like they do, but it's something like that. Trust building, making sure your relationship with AI is healthier than your relationship with pizza. Future horizons. The future again is so bright. You can't believe it will be bright. Quantum machine learning is like regular machine learning, but with more spooky action at a distance. Emotional intelligence in agents, teaching robots to understand your mood swings better than your spouse. Swarm intelligence, because if a bunch of ants can do it, why can't our agents? In conclusion, we're cooking up a future where intelligent agents are like the ultimate Swiss Army knife, solving problems, cracking jokes, and maybe even figuring out why your printer never works when you really need it. It's a brave new world out there, where your fridge might judge your midnight snack choices, but at least you'll order milk before you run out. Remember, with great power comes great responsibility and a lot of debugging. So let's strap in and enjoy this wild ride into the future of intelligent agents. Who knows? Maybe one day they'll finally figure out how to fold a fitted sheet. These are some of the reference materials I used when researching for this presentation, part 1 and part 2. Please feel free to freeze the video here if you'd like to take a look. And this is the end of part 2 of this presentation. I hope to see you at the upcoming AI/ML presentations. Thank you very much for watching. Goodbye.